Today we're going to start looking at geometric sequences of numbers. A sequence is just an ordered list of numbers. Now when we're looking at our sequences, we're going to be identifying each term using the letter A. So A sub n, the sub n, don't let that scare you, it's just what number it is in the list or in the sequence. So A sub 1 would be our first number in the sequence. A sub 2 would be our second number in the sequence, and so on. They use A sub n. Whatever number you put in for n is what number in the sequence you are. Okay, so everyone has a specific one. So if we look at this example, our first term, that would be A sub 1, is going to be 40. That's our first term. Our second term, A sub 2, is 20. Our third term and our fourth term. So it's simple once you understand that it's just the sub 1 is just what number in the list is it. And then the other thing is we're talking about a geometric sequence. A geometric sequence always has what we call a common ratio. What that means is the ratio between your numbers is always the same. So to find our common ratio, what we're going to do is we're going to divide our second number by our first and see what the ratio is. So 20 divided by 40 equals 1/2. And then let's just see. 10 divided by 20, also 1/2. 5 divided by 10, 1/2. So we know it's a geometric sequence with a common ratio of 1/2. So those are all the parts and the pieces to geometric sequences. So now we're just going to look at a couple of geometric sequences, or actually just a couple of sequences, and determine if they're geometric or not. And now to remember, to be geometric, they're going to have a common ratio that's the same every single time. So what I want you to do is to pause your video, and I want you to figure out 1, 2, 3, and 4. I want you to write the answers to them, and then check back for the explanation. Okay, I think you'll find sequences, geometric sequences, to be very easy to understand. They're a pattern. We've been working with patterns all year. Number 1, definitely the ratio stays the same. It's -4. Number 2 is the only one that the ratio doesn't stay the same, and so it's not geometric. And then on number 4, when we had to list our 3 terms after the first term, as long as you remember that A sub 1 means the first term, then it's very simple to multiply each term times 1/2 to get the next term. Okay, so on number 5, we're going to graph our geometric sequence. So the way that we do this is we're going to let each place in the sequence be our x value. So our 6 is the first place, or the first term. Our 12 is the second term. The 24 is the third, and the 48 is the fourth. So my first term, that's the position, is 6. My second position, 2, is 12. The number in my third position is 24. And the number in my fourth position is 48. So now that I've put my geometric sequence into a table, I can graph it. So what I want you to do, I want you to number your graph, your y-axis going up by 6s, your x-axis going up by halves, and graph these 4 points, and then pause your video while you're doing it and check back for the final explanation. Okay, so when you graph this, what you'll notice, hopefully, if you graphed it correctly, is that this is forming an exponential curve. So our geometric sequences form exponential curves.